Hey everyone, welcome back to Teacher K French. Thank you for those that have liked and shared and subscribed. Please continue to do so and boost this mathematics channel. We left off with dividing by primes, so let's pick up where we left off. So we're going to practice some dividing by primes, and today we're going to do factoring trees. All right, we talked about factors being that goes into the factory, goes into the machine. Talked about multiples and how that means multiplied, but today we're going to do a prime factor trees by prime numbers. Again, a prime number is either 1 times the number itself. We talked about prime and composite numbers. Composite means many parts. But let's get on to dividing by primes as a quick review. So I have 16. We're going to find the prime factors of 16 by dividing out the primes. All right, 16 is an even number, so I need to start with the first prime number, which is 2. Remember, 2 is the only even number that is prime. So I put a 2 right here. 16 then divided by 2, that's right, gives you 8. Now we're going to divide 8 out by 2, gives you 4, 2, 2. So 16 equals 2 times 2 times 2 times 2, or 2 to the 4th power. Again, we have to make sure we have divided all the primes out, so those are without the brackets. If it's a composite number, it stays in a bracket. All right, we have 50 over here. It sounds like a big number, but it's an even number, so we can start 50 divided by 2. If you have 2 quarters, you equal 50 cents, but if you took one away, you'd have 25 cents, so it's a good way to remember that. So 50 divided by 2 gives me 25. Now 25 isn't an even number, so 2 doesn't work. It's not divisible by 3, but it's divisible by 5. 5 is a prime. 25 divided by 5 gives you 5. So 50 equals 2 times 5 times 5, or 2 times 5 to the 2nd power. So now we're going to take the prime numbers that we're working on here, and we're going to make a factor tree. The factor tree is another way to help find the prime numbers of a number, and we can use any pair of factors. Okay, remember when we did 16? And remember when we did the factor pairs? We said we start with 1 times the number itself. You can do 2 times 8. And I think 16, then you have 4 times 4. Now we could take any of these factor pairs and find the factors of 16. Okay, remember a pair is 2. So 1 times 16 equals 16. 2 times 8 is 16. 4 times 4 is 16. Well, let's take the 2 times 8. All right, so 2 and 8. Let's put 2 times 8. Let's separate them over here. Well, let's factor out the prime numbers of 2. Well, 2 is already a prime number, so I can just leave it that. 8 goes to 2 times 4. Well, 2 is already prime. 2 is prime, but remember 4 is 2 times 2. And look what you found out here. And I was going off the screen a little bit. I apologize for that. 16 would equal, again, 2 times 2 times 2 times 2. So we can use a factor tree to also find the prime numbers. So let's try another number here. All right, so we have 36. Let's go with 36. What is a pair of factors that go into 36? Well, again, we're doing the pairs. You have 1 times 36. You could have 2 times 13, 3 times 12, or 6 times 6. We can take any of these pairs and find the prime factors. So let's take 3 times 12, okay? So we're going to let's put 36 up here. 3 times 12, all right? 3, factor out 3. Well, 3 is prime, so let's just bring that tree down to 3. 12, to get 12, I get 3 times 4. 3 is already prime, but 4 is 2 times 2. And you want to have your branches even. That's why we still, even if we're already prime, we kind of just bring the branch kind of down. So if we wanted to find 12, 12 would equal 2 times 2 times 3 times 3. Well, I mean, that equals 36. Sorry, I wrote 12 here because I was looking up here. So 36 equals 2 times 2 times 3 times 3, which would be 2 to the second power times 3 to the second power. All right, so again, a factor tree is another way of finding the prime factors of a number. Let's take 25. Well, we have 1 times 25, and we have 5 times 5. Well, if we wanted to put 25 as a factor tree, we'd have 5 and 5. Well, they're already prime numbers. So 25 equals 5 times 5. Let's put up another one up here. Let's go with 64. All right, so you could do 1 times 64. You can do 2 times 32. Does 4 go into 64? I think it does. 64 divided by 4 gives you 1. 24, yep. So you have 18. So 4 times 18. We're going to end, no, 5 doesn't work. 6 won't work. Then you could have 8 times 8. So which pair of factor pairs do we want to take? Which pair do you want to take? Let's take 8 times 8. So 64. 8 and 8. Well, we have factored 8 out with 2 to 4. The 2 is already prime. This is going to go to 2 to 2. Well, we're going to do the 8 here over here the same way. 2 to 4. So I come up with all my prime factors here. So we're going to find out that 64 equals 2 times 2 times 2 times 2 times 2 times 2, or 2 to the 6th power. I have 1, 2, 3, 4, 5, 6 2's. All right, so these are our factor trees. We're taking a factor pair and breaking it down by the prime factors. Again, we can divide by primes, or we can do a factor tree to find the prime numbers. Let's do one more. Let's go ahead and do 20. Let's think, we have our factor pairs, 1 times 20, 2 times 10, 4 times 5. So let's use 4 times 5. All right. What are the prime factors of 4? Well, 4 can be factored out 2 times 2, so those are prime. 5 is already prime, so I'll bring my tree down. Again, I want the same number of branches here. So 20 will equal 2 times 2 times 5. If I use exponents, that's 2 to the 2nd power times 5. Again, factor trees can just be another way of finding the prime factors of a number. Later on, in the next video, we're going to take our prime numbers, dividing by primes, to find our least common multiple and our greatest common factor. All right, I'll see you next time.